we continue with 8.3. Test for proportion. Most of what we are doing in chapter 7 and chapter 8, we did it already in chapter 7. So we are just going to learn how to use, under the same conditions and in chapter 7, how to test for the hypothesis. In chapter 7, we find an interval estimate for a parameter. In chapter 8, we want to test the validity of a statement about a parameter. So for proportion, we use the z-test for proportion provided same condition, np is greater than or equals to 5, nq is greater than or equals to 5. So we also have 3 types of tests: left tail for less than, right tail for greater than, and two tail for different from. The type of test is determined by H1. So the test value for proportion is p hat minus p over square root of pq over n. So remember that we are trying to compare a parameter to a statistic to determine the validity of the information or the statement made about that parameter. So a statement is made about a parameter, and we take a sample to obtain a corresponding statistics that we want to compare to the parameter to determine if the information or the statement about that parameter is actually true or false. So we will follow the same procedure as in the test for the mean. We identify the claim, which is generally in the quotient. We state the hypothesis. If the claim involves an inequality, if it is strict, it is H1. If it is greater than or equals to, less than or equals to, or equals to, it will be H0, and the opposite of it will be H1. So we will use calculator to compute either the test value and the p-value, and I will also explain what it means to use the critical value to do that. Our decision is about rejecting or not reject the null hypothesis. If the p-value is less than alpha, we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. So that is just, I'm trying to recall what we did on Tuesday. Let's start with this example. Can somebody read this example? Any of you? So we have an old method, and what was the probability of success for that old method? What was the probability of success for the old method? So what is the claim? What is the claim here? The new method is better than the old one. that is P is less than 0.3. Beta is greater than 0.3. So what is the sample size here? What is the sample size? 25. What is the number of success? 88. So the sample proportion is 88, but 225. Which is equal to 0.39. So the null hypothesis will be P equal to 0.3. Alternative hypothesis, P is greater than 0.3. The test value will be Z equals to P hat minus P over square root of P cubed over N, which is 0.39 minus 0.3 divided by square root of 0.3 and 7. So this gives us 2.95. At this point, I want you to use your calculator. You don't need to do this operation this way on the exam. You will use your calculator and it will give you the test value. What on your exam, I will ask you to identify the claim, state the hypothesis. What is the test value? Z equals to what you get from your calculator. What's the p-value? You give me the value you get from your calculator. We are going to see it as you use your calculator. So you will go to start and Z proportion test. I think might be the third one. The fit 5, 1 proportion Z test. If you have a question, let me know. P0 is what you get from H0, P0, 0.3. And X, 88, N, 225. This is a right tail test, so you choose greater than for what is the test value from your calculator? Are you able to get 2.95 for Z? Are you having trouble using your calculator? Are you able to get the test value Z? What is it? What is Z from your calculator? $2.98. You might not get exactly the same thing as I tell you, but it is essentially all right. What is the p-value? P-value? From your calculator, you should see the p-value after the test value. You see p. 0.00. So alpha equals to what? Do you remember what alpha was? 1%. So we will say decision if p, here, what's the decision? Is p less than alpha or greater than alpha? Is p less than alpha or greater than alpha? P is less than alpha. So we get it. So what should be our conclusion? Here in this example, the claim is E is greater than 0.3. It's 0, E equals to 0.3, H1, E is greater than 0.3, and this is our claim. Z is E minus P, the square root of E cubed over N, which is 0.39 minus 0.3 over square root of 0.3 times 0.7 over 225. E hat is 88 over 225, which is 0.39. And this is 2.959698. So we will say that P value is equal to 0.0014. Decision P is less than alpha. So reject H0. And the conclusion will be at alpha equals to 0.01, there is enough evidence to support the claim that the new method is better than the old one. This is what it is about test for proportion. we could also use the critical value, which is not generally what I advise you to use, but I just want you to know what the critical value actually means. Critical value method so here alpha equals to 0.01. So that means that the probability of type 1 error is 0.001. Since it's a right tail test, alpha is here, and we determine the critical value, we are supposed to be here. The area to the right of the critical value is 0.01, so the critical value is 2.33. So you will make the decision by comparing the test value to the critical value. Our test value was z equals to 2.95. Will it be after or before the critical value? Is it less than or greater than the critical value? Pardon? Is 2.95 less than 2.33 or greater than? It's greater than, so it's in the critical region. So it should be somewhere here. The test value is actually the area to the right of the test value. That's the p-value. So as it is small, it means the test value is in the rejection region. So we can also test hypotheses about parameters using paired data or dependent samples. In dependent samples, data are collected in pairs because we want to compare two things at a time. For example, if I want to show that left hand is weaker than right hand for most people, then I'm going to measure left and right hand from the same individual. As we say that on chapter 7 as well. So those are paired data. We generally express it as a before and after. So to work on paired data, what we do is we find the difference between the pairs of values. 8.4 paired data. So data are paired as B, A. B like for before, and A for after. We define a new variable, a new value, D, equals to B minus A. That will reduce the paired value into a single value, which is called the difference. We find a mean of D as sum of the difference divided by N. So the hypotheses are, all these are on PowerPoint. We will have H0 mu D equals to 0, where mu D is mu before minus mu after. Either you say mu D equals to 0 or you say mu B equals to mu after. H1 for a left tail will be mu D is less than 0. or mu b is less than mu a. For a right tail, mu d is greater than 0, or for a two tail, mu d is different from 0. So the test value will be using t distribution with degree of freedom n-1. The test value is t equals to g bar, which is the mean of the difference, divided by SD, the standard deviation of the difference, over square root of n. Actually, you will use your calculator. So all of this formula, I am just presenting it so that you know you have seen it before. But you will be using a calculator to do that. Or we will use Excel for this. It's much easier to use Excel. Just slightly easier to use Excel. So let's look at an example. I need somebody to read this example. So essentially here, we are going to compare anxiety before counseling, anxiety after counseling. So using your calculator, enter anxiety before counseling in column A, and then anxiety after counseling in column B. So using Excel, enter anxiety before counseling in column A, and anxiety after counseling in column B. The claim here is counseling. Counseling reduces anxiety. This will mean the average anxiety before counseling is greater than after counseling. Anxiety before equal to anxiety after. Anxiety before is greater than anxiety. If you have your data in Excel, you go to data, then data analysis. And then you will choose, go towards the end. You will choose T, test for pairs, data for me. T test, pairs, data for me. You see that on the side? Okay. Then when you click on that, you will enter variable 1. Just highlight the first A. The variable 2, just highlight it. And then you will choose your results to come maybe on the same sheet or the next one, or a new one. So if you want it on the same sheet, just choose where you want it to go. So you will see that mu d, you can also say mu d equal to 0, or mu d is greater than 0. If you were doing this manually, you will want to find that third column for the difference, b minus a, take the mean and the standard deviation of that one, to use that formula I gave you. But we are not doing it manually, so I'm just saying what you are supposed to do. So if you have completed your test, can you tell us what the test value is? Give us the test value you have from Excel. Yes. Yes. 4.36 is the test statistic. We call it test value or test statistics. And what is the p-value? What is the p-value? You will see one tail or two tail. This is is it one tail or two tail? Greater than, is it one tail or two tail? It is, yeah, pardon? It's two tail when you can be less than or greater. So for different. So when it is different, it could be different because it's less than, it could be different because it's greater than. So two tail is different. So when it is less than or greater than, is one tail. So you will have p-value for one tail and two tail. Which one do you, what is it for one tail? To read, you can just expand your Excel. You will see one tail p-value. Yes. 0.001. 112. Can you all see this on your calculator? Your book is using an estimate for the p-value because it's expecting you to use table. Table cannot compute anything. Table is fixed. So when you are using table, you can only find an estimate for p-value. So what was the alpha? Anybody remember what alpha was? Alpha was 5%, 1%. $0.01 is P less than alpha or greater than alpha? P is less than alpha. So reject itself. Conclusion that alpha equal to 0.01. There is enough evidence to support the claim that counseling reduces anxiety. Because we reject itself, there is enough evidence to support the claim that counseling reduces anxiety. So you know that data are paired when they are expressed in pair, and they require that one comes before the other. So let's look at the last section, testing the difference for independent sample. So for testing the difference for independent sample, we are going to first state the hypothesis. Difference for independent means not paired. So H0 will be mu1 equals to mu2, or mu1 minus mu2 is equal to 0. H1 will be mu1 is less than mu2. Or mu1 is greater than mu2 for a right tail test. And then mu1 is different from mu2. So we also have 3 types of tests: left, right, two-tail. If sigma 1 and sigma 2 are known, use z-test. And the test value z is x1 bar plus x2 bar divided by sigma 1 square over n1, sigma 2 square over n2. If sigma 1 or sigma 2 are unknown, we use the t distribution, t equals to x1 bar minus x2 bar over square root of s1 square over n1 plus s2 square over n2. The degree of freedom is the minimum of n1 minus 1, n2 minus 1. We did this already in chapter 7. So let's look at an example. Need somebody to read? Okay, so we want to test If, let's look at the question. Assume that the time required to bring water to the boil is normally distributed for each stove. So we do not need large sample size here. Is there any difference either way between the performance of these two models? So we are going to say H0, H0. There is no difference. H1, there is a difference. We don't know whether the difference is that one is less than the other or greater than. So coming back to this information, you can enter it into calculator. Use your calculator by going back to start test. X1 bar equals to 11.4. Sigma 1, 2.5. And 1, 10. X2 bar equals to 9.9. Sigma 2 equals to 3. So are you able to get to the test, the right test? Two samples CS. You don't need to write all this, the test value will be X1 bar minus X2 bar divided by square root of sigma 1 square over N1 plus sigma 2 square over N2. Have you used your calculator? Any question about the use of calculator so far? What is the test value? What do you get as test value? 1.27. And the p-value? 0.2. What was alpha? Pardon? 5%. 0.05. Is this p-value greater than or less than alpha? P is greater than alpha, so do not reject itself. Conclusion? At alpha equals to 0.05, there is not enough evidence to support the claim that there is a difference between the two stoves. So this is a two-tailed test. Be careful about that when you are selecting H1. Otherwise, you might have double of the p-value. So the tests, when sigma are unknown, we can use the t-test essentially the same way as we are using the z-test. You are going to choose two sample t-tests. Or, yeah. So here, let's look at this example. Two competing headache remedies claim to give fast-acting reliefs. An experiment was performed to compare the mean length of time required for bodily absorption of brand A and brand B headache remedies. 12 people were randomly selected and given an oral dosage of brand A. Another 12 were randomly selected and given an equal dosage of brand B. The length of time in minutes of the drugs to reach a specified level in the blood were recorded. The mean standard deviations and sizes of the two samples are followed. So here we are given the sample mean and the sample standard deviation for each of them. So because we don't have sigma, we are going to use the t distribution. We need to know the question. Let's use a 5% level of significance to test the claim that there is no difference between the two brands. There is no difference between the two brands. Here, the claim now is H0. Based on the examples, we have x1 bar equals to 21.8, s1 equals to 8.7, and n1 equals to 12. X2 bar equals to 18.9, s2 equals to 7.5, and n2 equals to 12. So you can go to your calculator again and choose and use the statistics. When you have data, you can also use Excel. Excel can test difference, but it needs some data, not some statistics. So what is the t-value or the test statistics? So go to start test, to sample t-test, and enter the statistics. X1 bar 21.8, X2 bar 18.9, S1 8.7, S2 7.5 to get the test value. Calculate. Here you will have H0 is 0 on the calculator. H1 is different from. Any trouble using calculator? S1 minus x2 over square root of S1 squared over N1 plus S2 squared over N2. I am just doing this waiting for you to get what you 21.8 minus 18.9 divided by 8.7 square over 12 plus 7.5 square over 12. What do you get? I want your number from your calculator. 0.87 and the p-value 0.39. So we can see that this p-value is much larger than most of the alpha we have. Alpha is generally 5% or 1%. So we will say that, I don't know what this alpha was. %. Alpha equal to 0.05 is greater than alpha, so do not reject with 0. At alpha equal to 0.05, there is not enough evidence to support the claim that there is a difference between the two drops. But sometimes we may say there is not enough evidence to reject the claim that there is a difference between the two drugs. We can also test the difference between proportions following the same procedure. One thing that we want to recall about proportion, what we want to know about proportion is that to test the claim about proportion, testing the difference of proportion. So we have N1, X1, P1 hat is X1 over N1, P2 hat is X2 over N2. Now, because we don't know the actual proportion, we are going to use the pool proportion. Calculator is going to use it for you, but I just want to define. E bar equals to X1 plus X2 over N1 plus N2. This is to get a better approximation of the proportion. We put the two samples together and find a common proportion that will help us to take an approximate value of the sample proportion for difference. So we have P1, P2. We will have P bar Q bar 2, 1 over N1 plus 1 over N2. And then the test value will be P1 hat minus P2 hat divided by the square root of P bar Q bar 1 over N1 plus 1 over N2. It's not writing well. So we will use calculator. Let's do an example. The Matrix County Clerk wishes to improve voter registration. One method under consideration is to send reminder in the mail to all citizens in the county who are eligible to register. As part of a pilot study to determine if this method will actually improve voter registration, a random sample of 1,250 potential voters was taken. Then this sample was randomly divided into two groups. In group one, no reminder was given. 625 people received the reminder, are in the group, and only 295 registered. We are going to record this information. Testing for proportion, we are going to have H0, P1 equals to P2, or P1 minus P2 equals to 0. H1, P1 is less than P2. This is the proportion of voters that we register. In the group 1, no reminder was sent. Group 2, reminder was sent. And this is our claim. So we have N1, 625, X1, 295, N2, 625, X2, 350. So we can go to the calculator with this information. The claim here is P1 is less than P2. And we have N1 equal to 625, X1 495, 625, X2 350. 1 hat is 495 over 620. And P2 hat is 350 over 620. You are entering your values into your calculator. I'm doing this to keep myself busy. You have everything you need to enter into the calculator. So H0, P1 equals to P2, H1, P1 is less than P2. So using the calculator, we will find the test value. So alpha here is 0.05. E bar will be 295 plus 350 divided by 1,250. E bar, the full proportion is 295 350 over 1250. Which is 0.516. And Q bar 0.8484. Do you have the Z value? from the calculator? So Z equals to so Z value. Anybody has Z value from the calculator? Yeah, are you having trouble using the calculator? Two proportion Z test. Enter N1 for sample N1, X1 for number of success, N2 for sample 2, X2 for number of success. Choose H0 equals to 0. Which one we will choose less than 0. We do less than 0 because this is the same thing as P1 minus P2. It's less than 0. Anybody has Z? If you don't have it, maybe you have a problem, yes. Z equals to negative 3.11. And what is P? 9.26. Anybody else has 9.26 or Z? 9.26 times 10 raised to power negative 4. Don't forget that part, because P is a probability. It cannot be bigger than 1. Then you are not reading something here. Times 10 raised to power minus 4. So this will be 0.000926. Alpha equals to 0.05. P is less than alpha, so reject. It's 0. So at alpha equals to 0.05, there is enough evidence to support the claim that sending a reminder to voters will improve registration. Okay. So you can do homework. The next part that I am leaving out, which I have been explaining while doing this, is the critical value. For the Z test, you can use the critical value by taking the Z to the area to the left or right for a one-tailed test, or double area to the left or right for a two-tailed test. I mean, you just do alpha over 2 for a two-tailed test. Take the area to find the critical values and compare the test value to the critical value to know whether or not it is in the rejection region. P-value is good enough, and that's what I prefer that you use. So we are done with chapter 8. Work on the homework. All is due on Tuesday night. Both take home. And if you have a question, send me an email, or you can also request a Zoom meeting tomorrow, office hour. To meet me at office hour, just log into your Zoom from Canvas. I will get an email that you are there, and then I will connect. Okay, we are done. If you have a question, you can stay and ask, or feel free to go.